Your host today is Joe Kubiar, who is the lead architect at DuploCloud. Joe has been a software engineer and architect who builds and deploys cloud-native applications from the ground up, and he's been doing this on AWS, Azure, and GCP. Joe has been developing software for over the past 3 decades and was actually doing DevOps before it even had a name. He also has extensive hands-on experience building IAC from the ground up and sees massive value in democratizing DevOps solutions. So without further ado, here's Joe.
Hi, everyone. So I'm glad to see everyone here. I think before I get going to everything, let's just cover the basics. Many of us probably know these, but we'll just kind of cover these anyway. So infrastructure as code, what is it? It's at this point a pretty well-known methodology for provisioning infrastructure in the cloud. And this, depending on the tools you're using, some of these tools even extend past what you might think of as the cloud. They can really call anything with an API. Some of them might provision DNS and some well-known DNS providers. Some of them can even target your databases. I mean, many things can be done now with infrastructure as code. And the cool thing about this is just using application development principles. So you're writing code, right? And your code is covering all the stuff that you want to see in your cloud. And we do this with, templates, scripts, maybe even some policies about what different people who are running this code are allowed to do. This is all the kind of stuff that maybe you're used to seeing when you're dealing with code. And there's many tools. Terraform is the most popular. If you're talking about provisioning servers that are long running, or some people like to call those pets, then things like Ansible and Puppet are pretty common. And sometimes people even, will put things like, they might even consider Docker in this. I think purism, it's not really part of this, right? But yeah, some people do put that in this bucket. But okay, can we go to the next slide? So let's talk about the benefits. Let's get down to the business. So what we want to do is we want to treat our infrastructure just like our products code, right? So we want changes to be easy to make and to track. And that gets us to a point where we can have things be repeatable instead of just somebody going in and making a change in your cloud and we're not really sure what happened. We can see exactly what it's going to do in the code, and we know that we can repeat it. We can also review it. We can have code reviews, we can have PRs, etc. We can make changes iteratively, just like we do in our product code, right? So we can change things a little bit at a time. We can recover to a previous state. It's very easy to do if you have, source control management like Git or something, right? It's very easy to do that. And lastly, everything you've done is very visible, right? Instead of you having to tool around in the cloud and expand different resources and see what's going on underneath those resources, you can actually see what your code says it is, and then you can even run a tool to tell you does it match what your code says, right? So the kind of visibility you get is pretty great. So next slide. But now we have an interesting situation we've created. By going to infrastructure as code and embracing DevOps, now we have this problem that our developers aren't really operators and our operators are not devs. So we've got this unique skill set. So what happens is you say, I want to have someone write this code. Your IT team, you may have some really smart, experienced guys there, but many of them may not have a programming background. And even more so, many of them probably have that capability to learn it. Like I said, we can have a lot of smart, experienced guys here, but you also have to find one who wants to learn that, who wants to get a little bit out of the space that he's already in. And the same thing happens on the developer side, right? You can have a ton of smart developers. They're not usually going to be versed in what actually happens in this infrastructure. It's one thing to write the code, but you have to actually understand what the code is doing. And same as I mentioned with the ops roles, they actually have to want to do it, right? That's another thing that we find is, you can have a pool of talented guys that really don't want to learn this other skill, right? So you've created this space where now you've got this unique skill set, and it becomes even more of a unicorn when we think about the other subject matter expertise that's required. And I like that we're calling out compliance and security here, because that's one that's going to apply basically everywhere, right? Like no matter what subject area your infrastructure as code might be covering, you're probably going to want to make sure that it's secure and is compliant with whatever standards that you follow. And that means the person that's looking at that code has to understand that as well. Or that code may not be compliant, right? Or the infrastructure that it creates, rather, may not be compliant. So next slide.
Yeah, that's a really good point, Joe. I mean, talking about developers and not operators and operators and not developers is just a fantastic point. And this is where the need for CI/CD arises. And so Joe's going to kind of take you through a couple of use case scenarios about why do we need CI/CD?
Yeah. So I'll kind of tell a story that I've seen play out a bunch of different ways. Um, and it's pretty common, like we mentioned, this is a specialized skill set. So often we end up hiring someone when we want to do this, right? So let's look at a typical team and their journey through adding infrastructure as code and then moving on to CI/CD. So let's just pick like a really simple vanilla type of architecture. Let's say we've got 3 backend microservices, a front-end web app, and a SQL database. And just to make this conversation shorter, let's just say that they've already containerized their microservices. They know how to build Docker containers. They're good with that. Now, the team wants to deploy to Kubernetes, and they want to be running in AWS, but they don't have any experience automating any deployments or managing apps in Kubernetes or AWS for that matter. So they hire a DevOps guy, right? So this DevOps guy comes and he writes Terraform to automate their cloud infrastructure, and he writes them a Helm chart to automate their application deployment. Next slide. So basically at this point, your DevOps team has started out with a team of 1, right? Your DevOps guy, right? And we're calling him the DevOps guy, which is usually what ends up happening, right? He's the guy that does everything. And everybody's really happy. They're like, holy crud, he wrote all our automation. This is amazing. Whenever we want to deploy new code or we want to even update our architecture, we just ask him and he runs it, and it's pretty fast and just works. And it works so well it kind of feels like somebody's waving a magic wand. Like this is kind of better than what they had pictured. They'd never worked with this kind of thing before, and it seems almost too good to be true and too easy to be real. And the development manager gets really excited. He starts thinking, we've got this. It works when he runs it. Let's run this from CI/CD. Let's get this automated. And he's kind of maybe got some visions of becoming one of those hot companies that he sees in the news that are doing everything with automation. They deploy to production multiple times a day from a pipeline, right? That's what everybody's starting to envision. Next slide. So what we start doing now, the usage of this automation starts getting exposed to a few other team members, right? We don't want to have a bottleneck where just one guy can do it. So the development manager says, hey, let's get some other people involved. But the problem is not everybody understands what's going on, right? So, and the DevOps guy is like, hey, this is just code. It just does what you tell it to do. Whenever someone's bringing him a problem, he kind of comes from that point of view, like, hey, this, unless they find a bug, he goes and fixes it. But if there's no bug, he says, look, this is what the code says. So as an example, let's say you don't need a VM anymore in your architecture. So you remove it from the code. But the team wasn't necessarily ready to bring that VM down yet. Maybe they had to move some data off it or something, right? And so they run the automation, the VM gets deleted, people are upset, right? Or let's pick another common example. Let's say the services, they've changed the path and the port that the service listens on because of how they're structuring their load balancer, and they want the traffic to go a certain way. So the DevOps guy correctly changes the code to make it match, but when they run it, it changes it immediately, and they haven't had any way to migrate the traffic, right? So there was a brief downtime going on, right? So these are kind of looking like some warts. Now everybody's still pretty happy in general, right? I mean, they still say this is pretty neat looking magic wand, but sometimes it's starting to look a bit more like a heavy hammer, right? We can see above those spots in blue where some things got broken. And the DevOps guy is thinking about this, and he's saying, why don't we, with this CI/CD that you're planning, Mr. Manager, why don't we just limit it to the Helm chart? Let's reduce some blast radius. Like he's trying to think of how do we prevent people from making these accidental changes, and that would fix this first blue bullet where the VM was removed, right? This means the CI/CD won't do that, but the second bullet, that's your app, so that would have still happened, right? Let's move to the next slide. So now we're trying to roll this out to the team. So the DevOps guy adds some CI/CD. On every push to Git, this CI/CD is going to build new Docker images, and it's going to deploy the Helm chart, for now just to a dev environment. And so the Docker images work well, right? It's pretty simple. I think many teams have already done this before and seen, this is a pretty simple thing to do. But the team has some concerns with the Helm. They say, well, wait, what if we forget to make a change to this Helm chart? What if our app needs a change? What if, for example, there's a new environment variable we need, or some new volume mounts, or there are ports and paths that need to change? What happens? Will it take our app down? Or could our app even end up being misconfigured and start performing incorrectly at runtime because of those changes that were made? Next slide.
So yeah, that's a really interesting point. I mean, at first CI/CD sounds fantastic, but you can tell that there are signs of cracking and issues are bound to arise, which can put your DevOps engineer at odds really with the rest of the engineering team. So Joe's going to take you kind of further down what can actually happen and what the implications are.
Yeah, I like how you put that, putting him at odds with the engineering team. I see that a lot. Before I even jump into this slide, it's what nobody wants, but it does kind of tend to happen, and it doesn't even have to be like an adversarial thing. It's just, sometimes they're making everything run smoothly, sometimes they're making it go slower. And I understand. I mean, I've been this DevOps guy, right, in a previous life, saying all these things to people, and trying to get things to work out for the team. And sometimes when this goes the wrong way, the solution companies pick is just scale out that DevOps team, make them bigger. Well, we've got lots of problems to solve. We need more people, right? So they throw bodies at it, and then you just end up with a larger team at odds with another another team, right? So this is kind of what we're getting to. So does this make things easier or harder, right? What is it really doing? So the development manager is starting to feel, man, every time I need to deploy to production, everything has to go through this DevOps guy, and neither the manager nor the DevOps guy want DevOps to become a bottleneck. The DevOps guys maybe give as like kind of a standard answer. The rest of the team should learn DevOps, right? That's what it means. You make your developers do ops. Isn't that how DevOps is supposed to work, right? This kind of idealistic attitude and approach. And the manager is being a little more pragmatic. He's thinking he's going to have some trouble even getting the team motivated to take on these responsibilities, much less finding which guys in my team want to learn the skills. And he definitely doesn't want to hire the help to scale out the team. Next slide. So what are these pitfalls that we're seeing, right? What are we seeing in this talk? So there's three ones I can point out. The more infrastructure as code you have, the more that's done for you. Now, this is basically our goal, right? We want things to be done for us. But if we're just letting it do it for us and we're not thinking through it, it can be a problem, right? And so it becomes a heavy hammer. So it can change or even remove things that you might not expect. And we gave some examples of that prior. It can also perform upgrades of related systems that you might not expect or be unprepared for. This is a common problem people have in non-infrastructure as code, like in development. If you're not locking versions, you deployed something, everything was working with your code, you deploy it again, you're getting a new version of something, your code stops working, right? This is also something that can happen in infrastructure as code. So what we're coming to is, before you wield the heavy hammer, you should look at a diff or a plan of what it proposes to do. So this means inserting a human into the process, which is kind of counterintuitive when we're talking about CI/CD. So let's talk about what that might mean. Next slide. So if we insert a human into the process, how do we use CI/CD? So here's what we think is a much safer way. And it kind of goes on that reducing blast radius theme. So we make our CI/CD perform application delivery only, right? We only update Docker images, we only publish front-end assets. So in that example of this team's architecture, this means the CI/CD can never change the architecture because it isn't even touching it. It's only touching the Docker images and the front-end assets. So then the next bullet might answer the questions you might have left. Well, how do we do those other changes? So if our application requires any greater changes than the above, we should have a human being review it and decide what the steps should be. And this gives you a chance to answer the questions. is running the automation just going to solve this for me? Or is it going to create a downtime perhaps, right? You can actually answer that question before you roll out an architecture change in production. Next slide.
Yeah, that's really interesting. I mean, this was supposed to make things easier, but instead you're creating a whole other host of new issues. So now we're going to take you through kind of 3 application delivery variations, and Joe's going to kind of walk through each different one.
Yeah. So let's look at some common, simple ones. So an umbrella helm chart. This is something people do a lot. You're basically just shrink wrapping the delivery of your application alongside its dependencies. It's an awesome practice. A lot of people do this, but that means it can update all of it. So this little picture I have on the side, you can show I've got an app. Let's say you've got a database, Postgres, and you've got a queuing system, Redis. So this umbrella chart can update all of it, right? So before you deploy it, you should do a Helm diff, review that diff, see what it's going to change. If it looks good, you're good. If you see, hey, it's going to create a downtime for me, then you need to maybe review, how do I deploy this, right? So this may not be the best pattern for CI/CD in production because of that potential. In this case, I would prefer app delivery only for doing an unintended upgrade. Next slide. So let's look at a very similar thing in Terraform, but it has even more scope, right? Terraform can automate all the things, right? It can automate your Kubernetes resources. It can deploy Helm charts. It can deploy things in AWS. It goes on and on, the things that it can do. So I would say the same thing. Because it has so much scope, we shouldn't do an unattended run of Terraform in production, right? We shouldn't just let that happen in CI/CD. We should prefer app delivery only. And one tip you can do, it's not foolproof, but if you use the target flag to Terraform, you can tell it, hey, only update these things that I tell you. And it will generally do that. But if it finds a dependency that also needs to change, it will also change that too. So you should still run a plan and make sure that it's actually going to do what you think it does. Next slide. So let's look at one where this end-to-end infrastructure as code causes no problems. It's actually exactly what you want. So short-lived environments, right? A lot of people want to have a situation where I create a PR with some new code. I want my CI/CD to go create a brand new environment in response to that PR. And then when it's merged, I want it to destroy the environment. So clearly here, you don't have any risks, right? You should be able to run your entire automation suite to be able to create, update, or destroy an env. We don't care if something unexpected changes, data loss, et cetera. I mean, this not only is this a dev environment, but it's a short-lived dev environment. Now, some teams may say, hey, my dev environment is basically always like this. We don't care if anything gets destroyed, taken down, data is lost. We can always restore our seed data. It takes us a few minutes. It's no big deal. This approach might also be okay for your normal dev environments as well. You just kind of have to know what risk you're able to accept and what impact there is, if any, for that risk. So these are like some 3 examples of some patterns. Next slide. So the takeaways I would hope we have from this is IAC is awesome. It gives you a great way to make sure your stuff is repeatable, and you can also use it to review or audit your changes. The emphasis on that review or audit, right? Don't run it blindly. Take advantage of that review capability. And don't forget that it is a specialized skill. So you can bottleneck your processes if you've got your processes depending on one guy to run this. And you can make your life easier if you segregate your code bases. So if you just do a simple split, like things that you don't run very often, like your VPC, your databases, et cetera, if you have that in a separate project from things that you run often, not only have you given yourself less to work with, so it's simpler, you also can run your CI/CD against something that never touches your VPC or your database, et cetera, right? Because you've segregated them. So you can say, oh, I only run it on this project, and give yourself a little bit of a little bit of a risk reduction there. Next slide. So maybe what we should do is we should ask ourselves, what pieces are we comfortable deploying in an unattended fashion? And then use that answer to reduce our blast radius. So we should always try to use app delivery only to limit the scope of unattended upgrades. This is what we do at Duplo for our customers. And we should always have a human being review any changes to architecture, third-party services, configuration files, et cetera, right? That's another thing that we always want people to do, so that they don't accidentally take themselves down. That's basically what we think you should do.
All right. If anyone has any questions, please type it into the QA. Thank you so much, Joe. I really appreciate this. We're here for the next 15 or 20 minutes to answer questions. But also, if you'd like to get a custom assessment of DuploCloud, email sales@duplocloud.net. I will also